I want to talk today about converting back and forth between the amount of mass of a substance and the number of atoms or particles in that particular substance that we're looking at. And critical to us being able to do this is recognizing the fact that the molar mass relates the weight of something or the mass of something to the number of moles of that substance. And the number of moles is a measure of how much that substance is. So, for instance, I want to look first at the problem, how many atoms are there in 5.79 grams of lithium? Well, the path that we're going to take for this is to go from grams, which we're given, and we have to convert that to moles, and then from moles we're going to go to atoms. And critical to accomplishing this is looking at the periodic table where we see that the molar mass of lithium is 6.941 grams per mole. This we could write as an equality if we wanted to, where we say 1 mole equals 6.941 grams. And from that equality, we can get a set of conversion factors. Those conversion factors will either be 1 mole over 6.941 grams or 6.941 grams over 1 mole. Also critical to doing this problem is remembering the relationship between atoms and moles. That is, from Avogadro's number, there are 6.02 times 10 to the 23rd atoms in 1 mole. So to start this calculation, we're going to start with our known quantity, 5.79 grams of lithium, and we're going to multiply that by our conversion factor, 1 mole per 6.941 grams. If we stopped there, our units would be in terms of moles, and we know how many moles of lithium we have. Well, we want to go further and take the second step. We've taken the first step in our path from grams to moles. Now we want to go from moles to atoms. We use this conversion factor. 6.02 times 10 to the 23rd atoms is the equivalent of 1 mole. And the moles cancel, and we end up with, after we do the calculation, that this is equal to 5.02 times 10 to the 23rd atoms. I also want to look at essentially going in the opposite direction. I'm going to do that on the other side of the page. And what we're going to look at is going from how much do I need to weigh out to get 1.00 times 10 to the 23rd atoms of lithium. So the path in this case is essentially the opposite of the path that we just looked at. Instead of going from grams to moles to atoms, we go from atoms to moles to grams. You'll notice moles is sort of the intersection of atoms and grams. We always go through moles to go from the weight or mass of substance to how much of that substance we have in terms of number of particles. So starting this with the known quantity, 1.00 times 10 to the 23rd atoms, we multiply that by our first conversion factor, 1 mole per 6.02 times 10 to the 23rd atoms. And if we stop there, the atoms cancel out. We'd know how many moles of lithium atoms we would have in this many number of atoms. But we don't want to stop there. We want to go one step further and say that we're going to multiply this by our second conversion factor using the one that moles cancels out. So we have moles on the top here. We want moles on the bottom on the other side. So we multiply that by 6.941 grams per 1 mole. And when we get our answer from our calculator, we find out that the answer is 1.15 grams.